Okay, so if you look at the difference between reaction turbine and impulse turbine, what is the most different feature between both? You compare impulse and reaction turbine. You see there is something that is available in the impulse turbine but not available on the reaction turbine. Can you guess what is that? A component that is in the impulse turbine not available in the reaction turbine. Yes, nozzle. You will not find nozzle in the reaction turbine. It's only applicable in the impulse turbine. Can you guess what is the purpose of installing nozzle on that impulse turbine?
Speed.
Increase the velocity. You increase the velocity. Why do we need to increase the velocity? Okay, let's look at, this is your turbine. Okay, if you look at your turbine, the output soft power is a function of, see that one? Jet velocity. So you want to get the jet velocity as high as possible. That's why we have the nozzle. That is the only thing why you need the nozzle. Okay. Now let's look at the Pelton wheel. If you look at the Pelton wheel that we have there, can you see from the front? You know, you just see from the side. Do you see how the bucket looks like? It's like a spoon. 1 spoon or 2 spoons? Okay, sure. Have you ever seen how it looks like? Is it like this or like that? Like this? Only 1 spoon or 2 spoons combined? 2? 2 or 1? You just say 2. Huh? My hand problem. Something like 2 spoons you combine together like this, right? And then the water hit the middle, split into 2 and then goes flat. Right? It looks like this. It's a kind of a 2 spoons connected together, right? You know the reason why it is like that? Okay, and you know the reason why there is a chipping tips on it? It should not hit. Okay, you see, when you have a Pelton turbine, you put the bucket like this. Imagine the water is hitting this, and then it will deflect. What is the maximum you can get? Deflection. If you still remember chapter 5, what is the degree, what is the angle to give you the maximum jet power? 15? Sure. Oh, if I was your lecturer, I will give you this question. I like to give this question in my final. Fan, right? This is your jet. And then the other one, you put the fan like that. So the jet will be like, which one give you the higher power? A or B? A or B? A or B? Who said A? Yes, why? Why A?
Lower loss.
No losses.
I mean,
Okay,
lower,
but most
lower
of both of these are located in the frictionless floor.
Okay, because
Both. So which one is better? Why B? Still remember how the equation is? M dot in
minus out. Equals to
is it plus or this one plus? You do not know. We have to look at the velocity. Now, if we look at Fx only, Fx, right? Because that is the force that is needed to hold it, right? This thing will have inlet but no outlet, because outlet will be from the y direction, whereas the B will have inlet and outlet, and somehow you will find that P in is positive, M in is always negative. M out is always positive because N is the same with the out, but P out negative. So this one negative. Negative, negative, positive. So this one will give you 2 M in, P in, whereas A will give you M in, P in, because M out, P out is in Y direction. The same goes for this. So you want to have the jet strike the bucket and then return at 180 degree. That is what we want. But you cannot, because when it hit the bucket will start to move, right? And the water will coming back. It will hit the next bucket. What happens if it hits the next bucket? It will slow down, right? So you want it to be 180 to get the full force. But you cannot do that, because when it hits, it will hit the next bucket. That's why you can have it maximum, usually is 165. So it will hit and split to the side. Now you know why it is like that. So that this bucket is not hit by the water, so the water hit only this. And the water will split to the side, not hitting the next one. Move, then the next one get hit by the jet. Then you get all the rotation. Clear? They learn it from the mistake, you know. First they will make like that. In fact, when they make this one first, they are not using the spoon shape. They like that. Hit the water and start to rotate. But then they found out the problem with that. So they make the adjustment, and the one who first use this is Pelton. That's why this turbine is called a Pelton turbine. Is that clear? History, don't worry. No equation yet. No equation yet. Now the equation. So you can see here, mathematically this is how it looks like, right? You use that one to calculate this. Can you do that? Right? You have the force. If you want to get the power, it will be times F times radius times this thing become tau times omega power. Right? So it become like this, and cos beta. So you can see now that the maximum will be occur when beta is equal to 180. Right? 180 cos beta will become -1. -1, negative, so 1 plus 1. So it becomes, so the maximum you can get for this is 180. That is the maximum. Okay? And the other thing is, the theoretical maximum power is achieved when omega is equal to jet velocity divided by 2r. What is 2r? 2r is the diameter of the Pelton wheel. So when you get V jet over 2r, you plug in that, you will get the maximum theoretical shaft power. Okay? Maximum theoretical. Because in actual, you cannot get it. Never. Right? I told you, 180, when you have that, the next bucket will be hit by the return jet. So it will not be happen. So the maximum theoretical value is achieved when eta is equal to 180. Theoretically, you can get it, right? 180 and omega is equal to V jet over 2r. So that is the ideal thing. See, this is the maximum shaft ideal, which will never be achieved.